that true? Hang on just a second. That is a lie. Sorry about that. Between 0 and pi, here is your sine function. So here's pi over 2, and here's pi. And so what do we see? We see that between 0 and pi, the sine function is always positive or 0. So normally when you take something out of a square root, it would come out with absolute values on it. But because I've restricted the function to simply where the sine curve is positive, I don't need the absolute values, which is really nice because I don't like taking derivatives with absolute values. If I lost you on the explanation that I just gave there, what I'm trying to say is that we would, ideally, if we have the square root of x squared, we would like to say that that's x, but normally we have to bring it out as absolute value of x. But if x is greater than or equal to 0, then when I see the square root of x squared, it can just come out as an x, which is easier to work with in a lot of cases. So, all that said, and you didn't need to show as many steps as I did, but here was our original function, and we could have simplified it to be the sine of x. That means that when we go to find the derivative, we just simply ask what is the derivative of the sine of x, and it is the cosine of x. That is probably the best way to do this problem, but if you had taken the long route, you would have gotten there as well. Okay. I need to do one more of these, and it's actually 10 minutes till class time, so I better do this fast. All right, so this last one is a quotient rule problem, and we're told do not simplify the result, and that's often the case when I give you quotient rule problems. So I'm just going to fly through this. Remember that our quotient rule says if we have h of x is equal to f of x over g of x, then h prime of x is equal to, so how do I take the derivative of the quotient? It is the bottom function times the derivative of the top minus the top function times the derivative of the bottom function all over the bottom function squared. So following that as my guide, in this case our top function would be 4x to the 5th plus sine squared of x all over x squared plus 1. You certainly don't need to show any of this. I'm just using this to give me a guide. So let's follow along. We take the bottom function, there it is, x squared plus 1, times the derivative of the top function, which would be 20x to the 4th, plus 2 sine to the first power of x, times the cosine of x. And I've run out of room here. Let's see what we can do. Okay, so this was my bottom times the derivative. All of this is the derivative of the top minus the top function, which was 4x to the 5th plus sine squared of x times the derivative of the bottom, which would be 2x. I'll go ahead and write that plus 0. So this was my top, this was the bottom, all over the bottom function squared. Okay. By the way, I didn't make any comment on it. When I went to take the derivative of the sine squared of x, there's a chain rule there. So if you think of the sine squared as sine of x squared, if you think of that as a function, then its derivative is take the derivative of the outside part, leaving the inside part alone. Now multiply that by the derivative of the inside part, which is precisely what I did with this piece right here. Okay. Unfortunately, I have to go, so that's the most explanation I can give for this. If you have any questions, feel free to let me know.